Good afternoon, everyone. I hope you had a good lunch and a chance to have a bit of a break and then a couple of the keynote sessions. This afternoon, we are going to be cracking on, I think, in this room with a number of OSGi-related sessions, I think. And the first of these up is real-world OSGi in IoT. I'm Bruce Jackson, CTO at ThingStream, and I'm joined today for this presentation by Kai Hackbarth from Bosch Software Innovations. Kai's a software evangelist, I believe, there. And we're going to talk about a project and some work that our two organizations have been doing together in a number of customer areas. So the concept behind this talk is really a question of whether it's possible to use OSGi from edge of the network all the way through to the enterprise. And what we're going to show is how we have put together a solution, ThingStream and Bosch, that does exactly that, using software components across the board, that everywhere from gateway systems on the edge of the network connected to industrial machinery, all the way through to an enterprise uses OSGi across in every one of those areas. So let's talk a little bit, go through that scenario a little bit, and talk about the different components that you have in those different places. So first of all, edge devices. There are some of these kicking around. I see that the guys from Eurotech actually have one of these out on their stand out in the hall outside. OSGi was obviously originally developed for home gateways to allow remote management, diagnostic updates of those, installation of software applications, but in a system that was continually running and something that was adaptive to the environment that they might encounter inside a given deployment. One of the characteristics of those kind of home gateways when they were originally conceived was that an operator of those devices could deploy software that was independent from the hardware necessarily used. So they could choose to build systems, build applications that would run on edge gateways that were independent from the hardware they were running on. So Java made a very good choice, and OSGi was a framework that was created originally to allow that kind of modularity of software and the building of those type of abstract applications. Those same characteristics make, obviously, OSGi extremely good for use in edge computing devices in IoT. The same things happen. You might have a variety of different hardware, and in fact, we've often encountered situations where customers will have hybrid hardware with different types of devices on different, based on wanting to feed data into the same applications, but being variable in terms of the hardware they're using for different reasons, either because they have different sensors attached to them or because they're wanting different mechanical or physical characteristics in those devices to do size constraints, etc. They still have the same problems that those kind of gateways have. The hardware is very different. You might encounter different types of software, and you're looking for a software system that can adapt to those type of characteristics, that can dynamically work out what's in place and make services available to other parts of the application stack that runs on the edge based on changes to those hardwares, changes to the configuration. So OSGi is a natural choice on these kind of edge applications, and probably, in terms of the things that we encounter for these type of edge gateways, is probably one of them, probably the most prevalent system that we see. There are a number of vendors who obviously produce software stacks for these things, but obviously Bosch Software Innovations has a software stack that runs on edge gateways and provides capability to decouple the application from the details of the hardware interfaces that are provided by these kind of units and other things like bus architectures that you will find in industrial applications. So if you have a look at a typical edge software stack, this is quite typical of the system that Bosch Software Innovation provides. Obviously, there's more detail in there depending on what kind of bundles, etc., are deployed on the device. But typically, you'll have the hardware down at the bottom, an operating system. Mainly on these kind of gateway devices, it'll be a Linux variant of some type, although often it'll be something like Yocto that cuts down all of the flexibility, and often an image that is not particularly extensible or very hard to extend. It might be something that's burnt into Flash, for example, such that you can't really just add to it dynamically in the same way that you would do with a typical Linux distribution. However, it'll usually contain the Java virtual machine, and then on top of that, you'll have an OSGi framework. And the OSGi framework will be complete enough to provide a whole range of services to applications that are being built on the top of that. And by that, there are the typical things like, for example, the OSGi log service and declarative services, but also then abstractions away for some of the interfaces. So, for example, Modbus, where the Modbus is via Ethernet or via serial, for instance. And those drivers are obviously going down through the framework and down actually to manipulate the hardware. But from an application point of view, or anything up above that layer, you don't need to know the details of it. For example, Modbus obviously can be carried by 2 different protocols, but the application doesn't need to know about that type of thing. It just needs to know what devices are attached to that bus, what kind of parameters they can accept, and how you can read and write data from those things. And that's transparent from the bearer. So again, a good example of the modularity of OSGi, abstracting that kind of detail that you just don't need to know about. Similarly, GPIO, how the GPIO pins work on a device, how many of them have, are things that can be abstracted away from having to deal with the nitty-gritty of drivers and setting registers and bits, etc., quite nicely. In our application, we provide a service module at this layer, which provides an MQTT-based interface for communication, for message-based communication between applications that live above and our service that lives below. So again, the detail of how that works, what network bearers are being used to send that data, how that data is being transferred is something that the application level at that layer doesn't need to know about. So from that stack, which we're showing on the right-hand side here now, this is the hardware device shown on the right. For the ThingStreams part in this solution, and I'll talk a little bit more about that in a while, we obviously have a piece of client software that lives on that edge gateway that communicates across a variety of cellular networks in different ways to send data into our platform server side. The ThingStream platform is entirely written in OSGi server side. It's built on Amazon Web Services, and it uses a microservice architecture, but not necessarily the one something you would typically expect to see. It's based on OSGi services, so different application structures, and I'll talk about this a bit more, consume OSGi microservices to carry out their operations, which typically take things that you find in AWS, wrap them with a piece of code and a few abstractions to provide individual services that are of use for the platform. There is also a certain amount of reuse between components between the gateway and server. In order to carry out a lot of that data transfer and to make it efficient, there are components being used in ThingStreams platform that encode and decode that data, and those are shared components and shared OSGi bundles that are deployed on the client and the server. And at the top, obviously, we then connect via MQTT into the Bosch IoT suite, where that data ultimately flows, and from there into an enterprise. And at this point, I'm going to hand over to Kai.
Yeah, hello again. So maybe before I jump into this, so as Bruce just pointed out, so we from Bosch Software Innovations, we have our own OSGi based stack. For those of you who still remember Process, so that's basically coming from the Process acquisition. And apart from this, we also have a component that we call the Bosch IoT Remote Manager that is dealing with exactly this point, device management. So, so this is really about how to remotely, I'll just bring this here together, how to remotely manage or configure devices and gateways in order to reduce manual efforts, right? So you want to do this, let's say, for a lot of assets that are out there, right? And so you want to be able also to deploy software updates and these kind of things, right? So firmware updates, you want to monitor your devices, yeah? Is the device still alive? Or if there is some, let's say, some problems on the device side or on the asset side, that you're able to support this with, diagnostics that you can do remotely and to help troubleshooting, in the field. So that's basically what the Bosch IoT Remote Manager is doing here. And it's also OSGi based from the ground up. Yeah, so that's also a product that basically comes out of Process software. So now we are talking about a customer example. Unfortunately, we can't disclose just yet the name, but it's really about large engine manufacturers. And so these companies have currently lots of problems. So they have large engines for different applications and industries. So for example, for plants, for ships, and so on. So they are very different in size and power and so on, right? So today they have no way of remotely controlling these devices, and they also don't receive any live data from there. And basically, if there is a problem with this asset, that can today only be fixed with on-site technicians. Yeah. And that is, of course, that's problematic because some of these assets, they are moving, right? Some of these assets are somewhere in the world, yeah, where it's hard to get. So that's actually, it's a lot of cost that is produced here, right? So so what we do here is basically we have these large engines, and again, this is just an example. Yeah, that they could be much larger. They have ECUs on there that let's say do different functions. And then we have on-site our IoT gateway software stack based on OSGi, obviously. We have a CAN bus integration so that we are able to receive messages from the CAN bus and basically send this data to the remote manager in order to either store it or to build dashboards, mashups, and so on, right? And so the remote manager obviously has also a couple of other functions. First of all, customer have different requirements of what data really needs to be transmitted, right? I mean, you don't just want to send plain raw data all the time in the cloud because that's just extremely expensive, right? So you want to configure this, as let's call it cost effective, yeah, as possible. And the pain points they have is today they basically have a need for an end-to-end solution to basically reduce the stakeholder management efforts. They want to deploy this large scale, so we talk about hundreds of thousands of engines they build per year, yeah. And they want to be able to deliver software updates worldwide. And they deal with various types of devices. Some of them are legacy, yeah, and that increases the complexity quite a lot. As I mentioned, today they don't have real-time data available. Yeah, that's of high value for them also to improve, for example, the machine, yeah, over time. I mean, for newer revisions. And I mean, the companies we are talking to, they currently have company policies that only allow them to deploy this on a single cloud environment. Yeah, so they are either on AWS, on Azure, or whatever. And I think that's where we differentiate from other IoT vendors. Yeah, we are flexible, so we can run on AWS, we can run on Azure, we can run on our own Bosch IoT cloud. It's really depending on where the customer needs us to be. Yeah. All right, and I should have mentioned obviously that the message exchange between the gateway software and the remote manager is happening through ThingStream, right? So here you basically see what we are doing together. So we have here our gateway software stack, and ThingStream has developed a protocol adapter that works on our gateway software, but I would expect it works similar on Kuro and other implementations. And basically what happens here that we send messages into the ThingStream enterprise platform, and we receive MQTT messages either in our remote manager or in the Bosch IoT suite, which is, let's say, a couple of microservices. So some of you may know that the Bosch IoT Hub is based on the Hono project, and the IoT Sync service is based on the Dito project. These are microservices. It's not OSGi in this case, yeah. But this is something that we build basically for our own internal purposes. And not only for our internal purposes, but I mean, obviously we have Bosch internal stakeholders that also need this. And on top of this, we are currently working with ThinkStream on building a demo using the XDK. Probably you will find it somewhere here, in some of the exhibitions. So this is a sensor development kit. It's quite small. It comes with 8, 9 different sensors, and it sends this data either through Wi-Fi, through Bluetooth, or USB, to some gateway. But what we currently doing here in this case is we have an extension board for a 3G, 4G modem, so that we are able to send messages using the ThinkStream client into our Bosch IoT hub. Yeah? And so this is still work in progress, and we'll write a blog about it so that people actually can also use it themselves. And I guess this is my part. Thank you.
Thank you, Kai. So as we mentioned, the basis of this solution that we built together is to deal with engine management solutions in a general sense. There's many people who have these kind of big engines that are distributed all over the world, and having a generic solution that you can provide to people that's almost off the shelf is a useful thing. I'm going to talk to you about a specific case of something that we've done at ThinkStream, which is working with a customer, Rolls-Royce Power Systems, MTU. And as Kai referred to earlier, they have a similar problem, remote monitoring characteristics for predictive maintenance, things like vibration, temperature. In fact, vibration on its own is the single biggest indicator that there's a problem with the engine. So if you measure the average vibration through the engine run cycle, you can pretty much predict with a great deal of accuracy exactly when you can need to send an engineer out to fix it. But then there's obviously also things like engine status codes that you can pick up via CAN bus. And the intention of this all is to improve engineer call-out. And this might surprise you, but one of the characteristics is also really important. Most of these companies, like Rolls-Royce, for example, don't really supply engines direct to end users. They build them as an OEM and supply them through the chain. So, for example, Rolls-Royce will build an engine, sell it to Hitachi, who'll put it in a train, and the train will be sold to a train operating company somewhere in Europe. So there is a dislocation between facts that Rolls-Royce know when an engine leaves the factory and what ends up happening in the field. And in fact, one of the things that we were amazed about when we came to talk to Rolls-Royce was that over 50% of engineer call-outs resulted in an engineer going out to an engine that wasn't the engine they thought it was. When they arrived, they looked at the serial number of it and it wasn't the right one, because somewhere down that chain, the engine had either been put in a different train to the one they expected, or just simply wasn't in the location they thought it was going to be, because these things move around. While some of them will be in fixed locations like data center power backup, a lot of them don't, they move around. And there ends up being a scheduling issue with not just knowing where your engine is, but then if it goes on a train, you have to work out when that train's back in the depot, the maintenance cycle that the end user has as well. So simply knowing the location is a huge win in terms of cost saving for Rolls-Royce. So a bit of an example about what type of data you capture and how that's transmitted. In general, what's happening is the engine, if you look at this graph here of time against what's happening, there are various different engine runs. They're not typically running full time, so they run for periods of time. And in those periods of time, you can measure things like vibration, temperature, get CAN bus data, and also positions. And those things are effectively stored on the device, processed in some way on the edge device, and then at some regular period of time, those messages are sent. Now, that's obviously data flow from the edge device via data being collected by sensors, going from the edge device up through ThinkStream and into the Bosch IoT platform. But equally, there are messages going the other way as well, and those are management type messages to do things like change how long that period of time between publications are, instigate device management operations to change the configuration of the device, software updates for bundles that might reside on the devices. So it's a bidirectional communication to change the way that those things may be working. When the data comes into ThinkStream, a number of things happen with it. In order to improve and optimize the payloads over the air, those kind of data messages are packed into a pretty compressed format, which isn't necessarily what you want when they arrive in the enterprise. Typically, enterprises want things in XML or JSON. They want stuff that's readable by people and easy to process with the tools you have. They don't want something that perhaps an embedded software engineer has packed the bits as tightly as possible. So in fact, we have within our platform something that allows you to take data that comes in onto an MQTT topic and process it, and we call it our flow manager. One of the things that's interesting about the flow manager is it looks a lot like Node-RED, and those of you who were here last year might remember I did a slightly obscure presentation about mixing JavaScript with OSGi components, and in fact, that's exactly what the flow manager does. These elements that you see in the flow manager, while they look like Node-RED, which are simple, basically Node.js processing elements, the UI for this is Node-RED's UI, but when you deploy it, it actually deploys onto effectively an auto-scaling cluster of machines or machine instances that implement those components. So each one of those components is effectively an architectural system inside AWS connected by application queues. So the size of these nodes and how many machine instances are behind them auto-scales based on the number of messages flowing through the queues. So this tool, while it looks like a way of building an application, is actually building infrastructure for a customer behind the scenes. You can add JavaScript components to it, and the JavaScript elements are actually now implemented using Graal. So it uses Graal VM to implement the JavaScript elements inside here, so people can add arbitrary functions in, and they will cooperate inside an OSGi framework or an OSGi environment, multiple OSGi frameworks communicating together. Once you've done the data processing, ThingStream actually uses OSGi microservices and tooling and an Eclipse-based management system to manage every part of the system. That's from deployment of solutions. So all of the, we have built up something based on Eclipse features that allows you to have features overloaded on top of features containing bundles to set out all of the elements that make up the ThingStream platform. These are some snapshots of various things we do. For example, you can deploy the whole of our infrastructure through an Eclipse console. You can run tests on any of those stacks. You can set up configurations and features that implement different parts of the systems. You can kind of, you have a hierarchy of those, so you can just create those features and build them up into components and then deploy them. And one of the things that's nice about that is it means that if an engineer, for instance, wants to create a complete instance and complete replica of everything that our system has, you can literally do it with about 4 clicks. Take a complete replica of the system, deploy it, and because effectively all of the architecture and infrastructure is developed as code elements within this, when you do the deploy, everything comes up at the same time. So it's a very unusual way of doing this. It doesn't use the typical technologies like Kubernetes that you might use for doing all this kind of stuff. It's something that's entirely been built in-house based on OSGi and based on tooling inside Eclipse to manage and configure the whole of the platform. Ultimately, the data comes back out of here and goes into another system. And in this case, the intelligence in the system is provided, for example, by the Bosch IoT solution. But one of the things that is obvious, that's interesting, is it's from the user's point of view, it's OSGi end-to-end. So there's elements of this that are enterprise-type solutions. There's elements of this that for us are management and test and tooling. And there's elements, obviously, on the gateway that are components that look after all of the capture of data and the management of the devices at the edge. So yes, the answer to my question I set up earlier, is it possible to do OSGi from edge to enterprise? Absolutely it is. Thank you. Are there any questions for either of us? No. Yes. Hello.
Mm-hmm.
Yeah, ThingStream really is linked into Amazon, and it's to do with the fact that well, it's a choice we've made, but it's to do with the choice we made in terms of building the infrastructure. I mean, actually, one of the choices of using OSGi was to be able to allow us to abstract the services away from the way they're implemented. So we don't, for instance, none of our, if you think of a component that does something like, for example, manages a concept of what a device is. So we have internally an OSGi device service. So you can, you'll find an instance of the device service and then you'll read and write data about a device, for instance. And behind the scenes, that is using probably storing the data in DynamoDB with a thin veneer of code in there, and if it needs to be more performant, it probably has something like Elasticache stuck in there as well. So you, are, as a user of that service, are unaware of where that data is going or how it's working. So yes, theoretically, you could re-implement that over anything you want. It doesn't really matter. It could be any other service. But in practical terms, particularly with regards to the tooling that's been deployed and how that infrastructure dynamically comes into being, particularly with the flow manager, it would be a bit of a headache, to say the least, re-implementing on something else. Correct. Yeah, you could do a re-implementation of those base services, and again, it wouldn't affect the way that the platform works, because that's part of what you get from OSGi. We're working on the basis of the service granularity, not the implementation of the service. Any other questions? Oh, yes. So I think the question was, do you have to run everything in OSGi? Yep. Mm-hmm. Oh, for just the ThingStream component, you can run the ThingStream. If that's all you're wanting to have for the communication part of it, you can run it on a microcontroller. It's really small. There isn't the implementation of the ThingStream service in OSGi is obviously written in Java, significantly bigger, but you can there are implementations of it in for a number of different platforms, and you can get basically a C SDK that's will run in 12K of RAM, 12K of flash, sorry, and about 4K of RAM. So really small. There's not much in it. There's a modem management code, there's a bit of data processing, and there's a bit of connection management. Yeah, but there's not much. Well, I think that's it. No more questions. Thank you very much, everyone.